Okay, in the last video, I gave you a quick look at how to use basic trusses to model a roof super fast. In these next videos, I'm going to show you how to use each truss and all their properties. Stick around because it's going to get detailed. Like all dynamic families in Senior Revit, these trusses are built to be used in pretty much the same way. So first, I'll run through the parameters that are common to all families, and then we'll dive into the specific ones for each type. Based on their use, these truss families are divided into primary trusses and secondary trusses. The primary trusses, which we will cover in this chapter, are the standard truss, the girder truss, and the gable end truss. The secondary trusses are the jack truss, the hip truss, the creeper truss, and the valley truss. We will see these types in the next video. Primary trusses can be either truncated or monotruncated. A truncated truss means that the top portion has been cut off, as seen in this image. A monotruncated truss means that it only has a slope on one side. Of course, we will see how to use these types in the following videos. All the primary trusses share the following parameters. The truss length and roof pitch were already covered in the last video. But just to recap, the truss length, or truss span, is the outer distance between the supporting walls, as you can see in this diagram. Now, some parameters we didn't cover last time are the depths, chords depth for top and bottom chords, and webs depth for all the other members. When we say depth, we're talking about the height of the timber element. Next up is truss thickness. This is actually the thickness of the chords and web members that make up the truss. For easier construction, both the chords and webs share the same thickness. And ideally, the whole structure keeps the same thickness across all trusses. The proper and organized way to model roofs is like this. I'll use reference planes and global parameters to keep the roof under control. Here, I already have a reference plane showing where the girder truss will go, and I've got this length, which will come in handy later for the hip and secondary trusses. For now, I'm going to place the girder truss right here, just a bit off center so I can align it properly. I'll grab the align tool and make sure to check the lockbox. First, I'm going to align the center of the truss with the roof ridge. Heads up, there's a little trick here, so pay attention. Before clicking on the ridge, heads up, if you hover over it, Revit tells you the reference is called shape handle. But if you press tab key, that message updates and now shows reference. This is the spot where you actually need to click. Otherwise, this alignment won't work. Pay close attention here. Now, with the reference selected, I'm going to grab the midpoint of the truss to align it. Move your cursor near the midpoint and you'll see a blue line appear, confirming that you're about to select the center of the truss. Click on that blue line, and since we activated the lock option, the truss is automatically locked in place. Then, I do the same thing with the reference plane to make sure it's positioned correctly. I switch over to 3D view to check our progress and adjust the truss span to 75/100s and the roof slope to 20 degrees. So far, so good. But let's imagine the client suddenly wants more space in the house and decides to move this wall 50 centimeters up. They also want the roof slope to be 22 degrees instead of 20. Time to update the model. First, I move the walls 500 millimeters upward. Next, I tweak the roof outline to keep the 600 millimeter eaves consistent around the perimeter of the house. Before hitting accept, I also adjust the line slopes to match the new 22 degree value. Back in 3D view, you can see that the truss obviously doesn't line up anymore with the shape or dimensions of the roof. So technically, we'd have to adjust the truss dimensions again. Not a big deal if it's just one truss. But imagine the model is completely finished. That would be a major headache and a huge waste of time. That's why it's crucial to plan ahead for changes like this. I'm going to roll back to the previous model with its original dimensions, and I'll show you how to avoid this kind of problem altogether. Here, the truss is already aligned with both the ridge beam and the reference plane of the girder truss. The first thing I'm going to do is add a dimension indicating the exterior distance between these two walls, which is 7,500, and this value will define the span of the truss. Now I select the dimension, and up here at the top, you'll notice that this section called Label Dimension becomes active. I'm going to click the New button, and this opens the Global Parameters window. Here, I can give the parameter a name that makes it easy to recognize later. For example, I'll name it West Wing. But before I hit OK, this part is super important. I'm going to set this parameter as a reporting type parameter. This is critical because if I don't do this, the parameter becomes fixed, and I won't be able to modify it later when the design changes. Once I accept, you'll notice that the dimension now shows a small pencil icon, which tells us that this dimension is linked to a global parameter. To view or edit the global parameters we've created, we can go to the Manage tab and then click on Global Parameters. As you can see, right now we only have one parameter, but we can keep adding more, either by assigning them to dimensions like we just did, or directly from this window. For example, I'm going to click New and create another parameter called Roof Slope. I change the parameter type to Angle, and I place it inside the Dimensions group. I click OK, and in the value field, I enter the original slope, which was 20 degrees, before the client requested the change. I click OK again and go back to the structural roof plan. Now I select the truss and click on Edit Type. Out of the two global parameters we've created, the first one we're going to link is West Wing, and we'll connect it to the truss span parameter. To do that, I look for the truss span parameter, and on the right-hand side, I click this small button, which from now on, I'll refer to as the global button. This opens a window showing all the available global parameters that are compatible. Notice that only West Wing appears, and not the roof slope. That's because this window only shows global parameters that match the data type of the parameter we're trying to link. In this case, the truss span parameter is a length parameter, and since roof slope is an angle parameter, it doesn't show up in the list. Alright, so I'm going to link the truss span parameter to West Wing and click OK. As you can see, the truss span is now locked. If you ever need to unlock it, just click the global button again and choose None. In this case, I'll leave it linked. Now I'll do the same thing for the roof slope. I click the global button and assign the roof slope global parameter. For now, I click OK and head back to the main model. Now I'm going to repeat the same process we used earlier to adapt the project to the client's new requirements. First, I move the walls 500 millimeters upward, and as you can see, this dimension automatically updates to 8,000. But that's not all. If I select the truss and click Edit Type, you'll notice that the truss span updates automatically as well. Let me pause here for a second, because this is a very important concept when working with global parameters. I go back to Edit Global Parameters, select West Wing, and click Edit. If you remember, we defined this dimension as a reporting parameter, and that's absolutely critical. Let's see what happens if we don't do that. I'm going to temporarily turn that option off and accept the changes. Now I return to the plan view, and if I try to move the wall again, you'll notice that the wall below also starts moving. That's because Revit is now trying to force this value to stay at 8,000. In other words, the value becomes fixed, which is not what we want at all. So keep this in mind. Whenever you use dimensions to create global parameters, they must be set as report parameters. I'll undo that change and edit the parameter again to turn the report parameter option back on. I test it one more time by moving the wall, and now the dimension updates correctly. Switching back to the 3D view, we can see that there's still an issue. The truss is no longer centered between the walls. You can see how it sticks out a bit on this side and even more on the other side. So now I'm going to fix the roof outline based on the new dimensions. I double click the roof, move the outline lines 500 millimeters upward, and click OK. With that, the roof ridge adjusts, and because we previously aligned the center of the truss to the ridge line, when we go back to the 3D view, you can see that the truss updates automatically. This means that if you had 10 or even 15 trusses, all of them would update instantly. Now, the only thing left to fix is the slope. I go back to the plan view and double click the roof again to edit its geometry. Unfortunately, roof slopes can't be linked directly to global parameters. So here, I manually change the slope to 22 degrees and click OK. Back in the 3D view, you can see that while the roof slope is now 22 degrees, the truss slope is still at 20 degrees. So I go back one more time to edit global parameters and update the roof slope parameter to 22 degrees. I click OK, check the truss again, and now both slopes match perfectly. And this is the real power of this workflow. When your model is already finished and the slope changes, all the trusses update automatically using a single parameter. Stick around, because this same logic is going to save you a massive amount of time when we move into the secondary trusses. Let's now take a look at other parameters that can be modified in the primary trusses. Remember, the primary trusses are the standard truss, the girder truss, and the gable end truss, which I'll cover in more detail later on. That said, the way these parameters behave is exactly the same across all of them. If I create a cross section to look at the truss and then select it, you'll notice several parameters that can be modified at the instance level. Just as a quick reminder, type parameters are the ones you edit by clicking Edit Type, and those changes affect all trusses of that type. Instance parameters, on the other hand, can be edited directly without going into Edit Type, and they only affect the selected truss or trusses. For example, this girder truss might need a different truncated height here compared to another location on the roof, just like with several of the other instance parameters. Let's walk through a few of these. Inside the geometry section, we have two key parameters: truncated height and wall distance from center. The first one, truncated height, was already covered in the previous video. This value should be adjusted once you've defined the height of the hip trusses or any other trusses that bear directly on this support. You can adjust this value either numerically in the properties or visually using the blue arrows that appear in a section view like this one. Now, let's talk about this wall distance. This parameter is used when, for example, you have a load-bearing wall near the center where the truss also transfers load. To show this, I'm going to copy this wall and place it closer to the center. I measure the distance between the center of the wall and the center of the truss. Take note of that value and then select the truss to enter it into the wall distance parameter. As a general rule, if the wall is to the right of the truss center, the value is positive. If it's to the left, the value is negative. I assign the value with the correct sign, and the truss automatically adjusts so the load is transferred directly to that wall at a stable point. At this stage, you may have noticed that when you select the truss, or even just hover over it, Revit shows you labels indicating which side is left and which is right. Even if the section were created facing the opposite direction, you can still clearly identify where the wall is and apply the correct positive or negative value for eccentricity. Next up is the eaves section. These parameters control whether the truss includes eaves and what their dimensions are. For example, let's say there's a chimney right where the girder truss rests. In that case, I can simply select the truss and indicate that it does not require a left eave. Finally, we have the truss end cuts section. Here, we can define whether the truss needs a cut on the left side, the right side, or both. Let's say this wall rises on this side as part of the facade. Even if I set the eaves distance to 0, the truss would still extend into the wall. In that situation, besides reducing the eave, I also activate the option indicating that the truss requires a cut. The length of that cut can be entered numerically or adjusted interactively using the blue arrows. In this case, it's easier to just drag the arrow until it lines up with the face of the wall. Of course, this condition would require a beam anchored to the wall to properly support the truss. Now, when we talk about truncated trusses, notice that the top chord is cut at a 45-degree angle. This is done so the truss can connect directly to the hip trusses. Because of that, when placing a truncated truss, it's very important to verify that this cut is facing the correct direction. If it isn't, no problem, this is an easy fix. Just go to the plan view, select the truss, and use this control handle to mirror it. That instantly flips the cut, so it's oriented correctly. The most advanced family in this truss package is the gable end truss. This one is used when you have a gable roof and need eaves, as you can see here. In this case, I'm placing the gable end truss family. As you can see, the truss sits right here. But this family also includes these overhanging elements called outriggers, and you can choose how they're spaced. To modify that spacing, I go into Edit Type and adjust the OR spacing parameter. You can also change their thickness if needed by adjusting the OR width parameter. Usually, the outrigger spacing is standard, and this value is considered a maximum spacing. The family then distributes the outriggers evenly across the roof. Now, if you wanted to change that distribution manually, you can close this window and go to the instance parameters. There, you can activate the fixed spacing option. Once you do that, you can set the spacing yourself, and the adjustment happens at the bottom. You'll also notice these two parameters, indoor distance and outdoor distance. Indoor distance is the distance to the next truss inside the building. You can control it manually or just move the arrow from a plan view. Outdoor distance is the distance of the outriggers. You can adjust it in the same way as the indoor distance. In both cases, you can move the arrows to either the center of the interior truss or the edge of the roof plane, and the family will respect both the interior cut to align with the interior truss and the exterior distance to place it exactly at the roof edge. Another interesting aspect of these main trusses is that, just like in a section view, we can also identify their left and right sides directly in the plan view. I'm going to select the truss and isolate it so it's easier to see. When I hover over or select the truss, you'll notice an arrow at one end. This arrow indicates the starting point, or the left side of the truss, while the opposite end represents the right side. Now, another important aspect is choosing how we want to display the trusses in the structural plan. At the moment, they are shown as a continuous line. However, if I change the level of detail to medium or high, the truss is displayed with its actual thickness. And we can even see the cut I mentioned earlier. I'm going to switch back to the low level of detail, and to modify the color and line type, we have two options. The first option is to go to the Manage tab and select Object Styles. The second and more specific option is to click on the Plan View template, assuming you have one assigned to this view. Inside the template, we look for the Model Categories tab and expand the Structural Framing category. Here, we locate the subcategory called SR Main Truss, and from there, we can modify the line weight, line type, or line color depending on how we want the trusses to appear in the drawings. In this case, I'm going to change the colour to red, accept all the changes, and return to the structural plan. While I do that, remember that purchasing this family package includes the full sample model very similar to this one, or even more detailed, depending on when are you watching this video. This model includes stud walls, stud jambs, concrete footing beam, and slab, so you can use it as a reference and better understand how the Revit Senior families work. To download the families, click here. Or if you want to watch the next video where I continue explaining the secondary trusses and their properties, click here. This concludes the video on main trusses. See you in the next one.